Hello, today I want to show you guys a trick on how to do weak acid equilibrium problems using the small x approximation on not only the acids with Ka that are small enough, but also Kas that are bigger than, for example, 10 to the minus 5. This trick works when Ka divided by the starting concentration of weak acid is less than 1. So in, let's say, the oxalic acid dissociation, you can say that H2A dissociates into HA minus plus H plus. And these are all aqueous. The corresponding ice table for a 0.5 molar concentration would be, and the equilibrium expression would then be, for the first Ka, x squared over 0.5 minus x. If we were to use the small x approximation, we wouldn't get the correct answer here, because the Ka1 is equal to 5.6 times 10 to the minus 2. And this is too big for 0.5 molar concentration to get an accurate answer. If we were to get the exact answer, we would have to use the full quadratic formula after solving for the quadratic form. We would get in solving this for x, we end up getting 0.1417 molar. But there's an easier way to do this. So we check whether Ka1 over the starting concentration of H2A is much less than 1. And in fact, what we get for the ratio is 0.112. This is when we can use this trick. It doesn't matter how much smaller than 1 this ratio is, but it works best when it's much smaller than 1. If it's barely smaller than 1, that's fine, it'll just take a while to work. So, using this trick, we can actually say that x is equal to the square root of Ka1 times the starting concentration of H2A as our first approximation. However, we would get from just this .1673 molar concentration. If we modify this formula afterwards, what we would get is that the starting concentration minus the previous x gives us our converged x star. Using this, if we press enter several times, we eventually converge upon the answer, 1417. And again, this works as long as the ratio of the Ka divided by the starting acid concentration is less than 1. If it's equal to 1, you'll get 0 all the time. If it's greater than 1, then you'll get imaginary numbers. So try it out and tell me what you think. Use it on any weak acid whose Ka divided by its concentration is less than 1.